You ever look up at a sky that's just packed with gray clouds and think, why isn't it raining? I mean, it seems like everything's ready to go, but nothing. Well, today, we are talking about the scientist who not only asked that same question, but actually found an answer, and in doing so, figured out how to make it rain on command. So, what's the deal? For the longest time, the theory was that raindrops needed tiny dust particles to form around. But that never really explained the whole picture. Why some clouds let loose a total downpour, while others just float on by. This was the exact puzzle that a scientist named Irving Langmuir became fascinated with. Okay, so get this. The year is 1946. There's an airplane on a really strange mission. It's not carrying passengers. It's not carrying regular cargo. It's carrying something very specific. It climbs high above a thick layer of clouds and gets ready to drop its payload. Not bombs, but something that was about to change how we think about weather forever. Powdered dry ice. And the result? It was unbelievably fast. They dropped the dry ice, seeding the clouds below. And just 30 minutes later, it started to rain. This wasn't a coincidence, nope. It was a direct consequence of what they had just done. Everyone knew right away what this was. It was the first time in history that humans had intentionally and successfully made it rain, which of course leads to one big question: who was the guy who could pull the strings on the clouds? Well, the mind behind this incredible feat belonged to Irving Langmuir, a scientist whose curiosity was just off the charts. And believe me, the story of how he got to this point is just as amazing as the rain itself. So this timeline here gives you a really quick look at his incredible career. Born in Brooklyn, he joins General Electric in 1909 and ends up staying for almost 50 years. And get this, he won the Nobel Prize way back in 1932, long before he ever started messing with the weather. I mean, think about that. Nearly 50 years at one company. That's almost unheard of. But GE wasn't just a job for him. It was a place that saw his talent right away and, more importantly, knew exactly how to let it flourish. And this, right here, is the secret sauce. GE gave him complete freedom. They didn't box him in, telling him what to work on. They basically trusted his genius and let him chase his curiosity wherever it took him. And that freedom led to breakthroughs in areas he wasn't even supposed to be studying. So let's see how that freedom really paid off. Because before he ever looked up at the clouds, Langmuir's work was focused on things that were way, way smaller. From the tiny filaments inside light bulbs to invisible films just a single molecule thick. Okay, so check this out because it really shows you how his mind worked. His first big task at GE was to make light bulbs last longer. Back then, bulbs had a vacuum inside to keep the filament from burning up. But Langmuir figured out the atoms of the filament were just sort of boiling off into that vacuum, making it brittle. So what was the solution? He filled the bulb with an inert gas, like argon, which put pressure on the filament and stopped it from evaporating. Simple, brilliant, and it made light bulbs last so much longer. But he wasn't just making things last longer. He was also creating things with just unbelievable power. And then there was his hydrogen blowtorch that could get, well, just insanely hot. 6,000 degrees. Just to put that into perspective, that is nearly as hot as the surface of the sun. It's just a stunning example of how well he understood physics. So, how on earth did he do it? Well, the principle was just pure genius. He'd pass regular hydrogen gas, which exists as two atom molecules, over a super hot wire. The heat would rip those molecules apart into single atoms. Then, as those single atoms naturally snapped back together into pairs, they released all that stored energy as an incredible blast of heat. And this is where you really see his range. It wasn't just about practical inventions. Langmuir was a true pioneer. His deepest work, the research that actually got him that Nobel Prize, was in a field called surface chemistry, basically studying how different things act when they touch. He was the first person to really dig into stuff like this. He'd noticed that a drop of mineral oil on water just kind of beads up, but a different substance, suric acid, does something totally wild. It spreads out across the water into this huge, invisible film. And he proved that film was just one single molecule thick. It was a fundamental discovery that had huge implications for everything from non-glare glass to how our own cells work. Okay, so you've got this brilliant, wildly curious mind who's won a Nobel Prize for studying molecular films. So how does he go from that to unlocking the secret of the clouds?
So remember, the old idea was that you needed dust for rain. But Langmuir, with everything he knew about surfaces and particles, he just had this hunch that there was something else going on, something much more important. So, what do you do when you want to study a cloud? Well, if you're Irving Langmuir, you just build one. Right there in his lab, he made what was basically a homemade cloud in a box, a simple chamber he could fill with water vapor to run his tests. Now, the big breakthrough, like so many great discoveries, kind of happened by accident. It was a really hot summer day, and he couldn't get his cloud box cold enough, so he just decided to throw in a chunk of dry ice, which is really just frozen carbon dioxide, to cool things down fast.
And bam, that was the aha moment. The second the dry ice went in, the box was filled with a swirling storm of tiny ice crystals, a miniature snowstorm. The water vapor didn't need dust at all. It just needed to get super cold, around 40 degrees below zero, and it would turn straight into ice. It was temperature, not dust, that was the real trigger.
So that one little discovery in a lab freezer opened the door to a whole new world. Weather modification, Langmuir, had proved it could work in a box. Now the question was, what could it do in the real world? Now, Langmuir's original method, as we saw, was dropping dry ice from airplanes. But his work inspired his colleagues, a scientist named Werner Vonnegut. And a fun little fact, yes, he was the brother of the famous author Kurt Vonnegut. He discovered that tiny crystals of silver iodide worked even better. And the real game changer? You could release silver iodide from the ground and let it rise into the clouds, which was way easier and cheaper. Irving Langmuir passed away in 1957. But he lived long enough to see his little laboratory discovery, cloud seeding, grow from a scientific curiosity into a huge business, used all over the planet to try and bring rain to places that desperately need it. And that leaves us with this huge, tantalizing question for the future. The science started in a small box. Today we use it to make rain. But the ultimate dream, something scientists are still looking into, is whether we could use this same idea on a massive scale. Could we seed a developing hurricane, force it to rain itself out over the ocean, and weaken it before it ever becomes a monster? It's a wild thought, and it all started with one man's complete freedom to just be curious.